Before we finish the section 7.4, I will go over some two special cases when it comes to these problems under partial fractions. The first one is very simple. So what I want to highlight is when you have things like this, right? Just because you see a factorization in the denominator, don't try to apply partial fractions at once, right? Partial fractions will of course work, right? You can write this is a linear factor and the other one is a quadratic factor, irreducible quadratic factor, so you can write down the partial fractions and solve accordingly to find the integral. That's fine. But see, if you expand this bracket and write down the denominator like this, you can at once identify that the derivative of this term is equal to 3x squared plus 3. Okay, so that means 3 times x squared plus 1, and the x squared plus 1 term is there in the numerator. So if we simply multiply it with 3 and divide by 3, you can at once find the answer for the given problem, right? So, and also from the integration by parts method, you will again come back to this same formula. So be careful when you are doing the integration by parts. First check whether you can see this relationship. Okay, right. And the second problem is this one. Okay, now remember in the section 7.3 we came across situations where we had square roots, right? But there, inside the square root we had a x squared term along with an addition or subtraction with the number. We had a x squared term, okay? But here you only have a x term. And also when you have these square roots, you cannot go for partial fractions. So what we can do is, initially we can use the substitution for x plus 4, right? For the root of x plus 4. And now let's see what will happen. So if we square this one, you will get x plus 4. Therefore x will be equal to u squared minus 4. In other words, for all the x values, you can replace it with u squared minus 4, right? And as we are using the substitution, we should have a proper term to substitute for dx. And to find that one, we can differentiate this equation. Now, you can even differentiate this one, that's fine. But since you don't have any square roots in this equation, I am differentiating that instead. Okay, so yeah, it will be this one. So dx will be equal to du times 2 times u du. Okay, so in place of dx we can have this one. You will get the same result even when you differentiate the first equation. Okay, right. Now see what will happen when we substitute u squared minus 4 in place of x. The integral becomes square root of, for x I have u squared minus 4, but there is another additional 4 there, right? And here we have u squared minus 4 in the denominator, and for dx we can have 2 times du, right? 2 times means I can take that 2 out from the the integral sign, so I have u du, right? And see what happens. Now we have 2 times the integral of u squared square root. Okay, that means and this is u, and together with this u outside you will get u squared term. Okay, and so that divided by u squared minus 4, right? Now we can apply partial fractions because there are no square roots inside this expression. So, and also it is something of the nature where we came across in the theory of partial fractions. But the only problem here is it is an improper fraction. Okay, in both numerator and the denominator you have the same degree. So first you have to do the long division and then obtain the partial fractions accordingly. So if you do the partial fractions, you can see before going for partial fractions you should do the long division. Okay, so when you do the long division, this is what you will get, right? And then for this term, by doing the partial fractions, because you can factorize it like this, and then by doing the partial fractions and finding the unknown terms accordingly, you can obtain the answer as 2u plus 8 over 4 ln u minus 2 minus ln u plus 2. Okay, so this will be the answer. And there's one more thing that you should do, because the original integral is given in terms of x, right? But this answer is in terms of u, so you have to convert everything back into the original variable. Okay, that means simply we should replace u with the square root of x plus 4. Okay, so the final answer will be equal to this one. And also you can even combine these two terms and write it as a single logarithm term. Okay, right. So this concludes the section 7.4.